Hello everyone, my name is Lucian. Most of you know me from Twitter as Triangle Investor. In today's edition of CEO and Market Expert Interviews, I'm happy to host Malcolm Rawlingson. Malcolm is a nuclear engineer with more than 50 years of experience in the industry. He's a very well-known and followed name on Twitter. And if you want to see a smart stuff posting about uranium and nuclear energy, no BS stuff, I suggest you follow Malcolm. He's one of those guys who deserves my biggest respect. That said, Malcolm, thank you for coming to my show.
Oh, you're very welcome. Thanks for the intro. I'm going to get my head out the door now.
Thanks, Malcolm. You are present on Twitter for some time now, but you are not one of those loud people who is doing this to promote themselves and trying to impose your opinion by all means. And people like that and really respect you a lot. But for the ones who does not know much about you, let's go a few decades in the past. Who is Malcolm Rawlingson? How did you end up in nuclear business? Where did you educate? Please tell us more about yourself.
Well, I've got to put that in a nutshell. My degree is in nuclear engineering. I got that from Queen Mary College, University of London. My family has a lot of history with that part of London, so that was natural for me to go there.
Yeah.
And my brother went there as well, my older brother. I picked nuclear engineering. It sounds terrible to say this, but it sounded cool at the time. And it was. I mean, it is a fantastic industry to work in. Yeah. I've met, so many wonderful people, very dedicated and professional people that work in the industry.
Mm-hmm.
So I took university degrees in the UK 3 years. So I did my 3 year stint there. Started in 1969, finished in 72. Then I got a bit of a shock because, one of the many nuclear industry downturns in the UK meant that there were no jobs. The main hiring companies, the Nuclear Power Group was one of them, were not hiring. So I ended up working in a government research lab, weapons research lab, I might add. Mm-hmm. And so I stayed there for 6 years, learned a lot about research and science and how to do scientific studies from people that have spent their lives doing it. So I have a good background in the scientific way of doing things, which is probably why I don't post too much bullshit on Twitter because, it's just against the grain totally. So then I had a wife and wanted to start a family, and problem with that is you need money, and government scientists don't get paid very well. So unfortunately,
not even today.
I had to leave that job. I loved the job, really did, but had to leave it, and I became a nuclear operator at Bradwell Power Station in Essex, England. That was a lot of fun too. Learned a lot there about heavy industry and how things really work, and a lot about the power industry as well, and a lot about managing people, which was huge help later on in life. But yeah, it was a good job. I learned a lot about these are old reactors. They were designed in the 50s. Yeah. These were the next development from the Calder Hall Chapel Cross reactors in the UK. So they were pretty basic designs. They didn't have a lot of the safety features that modern reactors do. Big, lumbering, heavy-duty machines. But as a place to learn the industry, second to none. I learned from some of the people that actually built it. So they knew every inch of the plant, and showed me a lot. And I have huge thanks I got to give for those guys because they took time to educate me, which is something I do now. That's part of why I'm on Twitter, to try and educate people. It's a complicated business to start with, and when you get these superficial tweets on Twitter, that are clearly skimming the surface of the subject, I have to intervene and say something. Yeah, I'm not always right, nobody's ever always right, but opinions are one thing, facts are another.
Exactly.
one of the reasons I like Quake's because he's a fact guy. The other. So what did I do after that? Well, I was offered a job in Canada to work on the Ontario nuclear power program. That was in '82. I came over to Canada in '82, which was a wonderful move for me. I mean, especially for my family. And so all my children are born here. And it's been, the nuclear industry in Ontario has been fabulous to me, really. I can't say enough about them. You know, there's OPG. I joined Ontario Hydro and it became OPG, Ontario Power Generation, later. But fantastic companies. Really, you know, they do stuff by the book absolutely perfectly every time. You know, they make the odd mistake every now and again, but you know, things like cost overruns and things like that. But it's really easier to do in the nuclear business. You don't have to get too much wrong to be costing you a lot more money. So I specialised in the fire protection of nuclear power plants over the years. I did a lot of different things. I was worked in design, worked in emergency preparedness, lots of different areas within the nuclear industry. So I have a pretty well-rounded look or view of how nuclear works and all the components that are needed to make it work. And, you know, and for public acceptance as well. You know, people get alarmed when we're testing the emergency sirens, but, you know, we're just testing them to make sure they work.
Exactly.
But people get upset about that. And, you know, I can't blame them. I can't blame them at all.
That's very, very impressive background. But you are not finished. We are now in the late 80s. Where is the rest?
Well, then I specialized in fire protection, which is my, you know, my business is now, supporting the nuclear industry in that area, which in itself is quite a complicated subject. It's not like fire protection outside. You have, you know, fire on shutdown system cables is in a nuclear power plant has a whole lot of things associated with it than fire on a you know, in a commercial building. You know, both serious, but one has really serious consequences if it goes wrong. Browns Ferry, they had a fire there, which really is a case in point as to what fire can do to nuclear power plants. I saw it as an area of vulnerability that nobody was looking at good enough, in my view. So I you know, became, I guess, an expert in that particular area, and it's been great. I really enjoy it, and I started contracting. I left OPG in, I believe, 2008. I've been contracting for 15 years, and been all over the place. Bruce Power, nuclear, Chalk River Nuclear Labs, all over Ontario. We've done work for all of them pretty much, and most of the subcontractors too. So I'm pretty well known in the industry. Most people know who I am.
That's
not sure that's a good thing or a bad thing.
It's a good thing, especially probably for your portfolio with the knowledge you have. It's a good thing, I believe. Malcolm, one of my first questions for you is the quality of new built reactors. I mean, how far has the technology advanced in the last couple of years, decades? How much are the safety standards have improved?
Oh, a lot. That's not saying that existing reactors are not safe. It's just a whole other level of safety. In fact, many of the features that are already built into CANDU reactors, which is what we operate in Ontario, we don't have any other type of reactor because it's a natural uranium reactor, and we don't have an enrichment plant in Canada. So it was the right thing to do for Canada to do that. Ontario also had a natural uranium supply in the northern part of Ontario, Elliott Lake. So it was really a homegrown industry in Ontario for the most part. Some plants got built in Point Lepreau in New Brunswick, and one in Gentilly in Quebec. That one shut down now, though. But as far as safety goes, a lot of the CANDU features are passive safety systems. So, you know, if you shut off all cooling supplies, you know, you can still shut down the reactor. So if you lose electrical supplies, then the shutoff rods drop into the core. Other things happen to shut down the reactor. So this idea of passive safety systems is inherent in CANDUs and has been developed over the years and incorporated into many of the new designs. So for example, in CANDUs, we have two fast shutdown systems, shutdown system 1 and 2, both completely independent of each other, like electrically and electronically independent. So all of the detection systems are completely different for the two, and even the components are made by different manufacturers. So all of that type of philosophy has gone into the newer reactors. Light water reactors don't necessarily require 2 shutdown systems, because if in a light water reactor, if once the shutoff rods have dropped into the core, the thing will shut itself down anyway. Even if it gets too hot, because in a light water reactor, if it gets too hot and starts to boil the water, you lose the neutron slowing down capability. So it automatically shuts itself down. It's not a good thing by any means, because you are likely to overheat the fuel. But from a nuclear safety point of view, you can't get to a Chernobyl that way. So there's a lot of different safety features been built in. The SMRs, for example, some of them are smaller versions or redesigned smaller versions of existing big reactors, but the technology is the same. PWRs, the Westinghouse SMR is a small PWR, and the GE Hitachi one, they're building 4 of those down at Rawlingson here, and those are smaller versions of the boiling water reactor. But they have, having said that, they are not the same. They have a lot of safety features installed in them. Mostly they're built underground, so they're in a pod underground, so that the shielding is provided by the earth. It's concrete lined, of course, but basically that's how they're going to be built. Haven't seen the detailed designs of them yet, but that's likely how they're going to be built, rather than above ground, which is how all the reactors are built nowadays. In the past, all of our reactors are built above ground, and the shielding has to be built around them, so that costs you money. Much cheaper to use the rock as the shielding. Very smart move. Cheaper.
Yeah, I can imagine that. What are the main differences between, let's say, Russian design reactor, Chinese design reactor, and the ones built in the West?
That's a good question. It depends on the reactor, of course.
Of course.
Like most reactors in the world are light water reactors, and most of those are pressurized light water reactors. So they, instead of allowing the water to boil inside the reactor vessel, there's pressure put on top of it, about 2000 psi, to stop that boiling from occurring. So the VVER, Russian design, the Chinese Hualong 1, and the Westinghouse designs, they're all pretty much the same. The technology is the same. The fuel elements look the same. There's not really that much of a difference between them. There are differences in the numbers of valves. They try to reduce the numbers of valves over the years, because valves need maintenance, and if they are radioactive in a radioactive circuit, then that's an extra maintenance burden. So you want to reduce the number of valves as much as possible. Again, something that CANDU did. CANDU did it because putting valves in heavy water systems meant you were risking losing heavy water, which was extremely expensive. So they eliminated a lot of valves in CANDU reactors. Light water reactors have gone the same route, and because of maintenance issues, they reduced the number of valves substantially. Not to zero, because you can't, but most of the newer designs have very, very few valves, and it's a failure point. And the more breaks you have in a pipe, the more likely it is to fail. Very unlikely that it would, but it increases the probability a little bit.
And Malcolm, what is your take? You touched on SMRs. What is your take on SMRs? What do you see as the main obstacles of a wide expansion of SMRs, if there is any?
This is a really good question, because that term, small modular reactors, covers a whole very wide range of different reactor designs. Some of them are proven concepts, like light water reactors. The GE1 and the Westinghouse one are based on proven designs, similar to the ones that are put in ships, nuclear-powered submarines and aircraft carriers. A few differences, but basically the engineering is very similar. The beauty of SMRs is that there are so many different types of them, and they all have different applications. So all of them could be used to produce electricity, but some of them can be used, like the HTGR, high temperature gas cooled reactor, can be used to work on a gas turbine cycle directly. So instead of having a steam turbine where you lose huge amounts of energy to the cooling water in the lake or river or sea, you're using the gas, high temperature gas, straight into the turbine. So it's a gas turbine you can use directly on that, which cuts out a lot of the inefficiencies of steam cycles. So that's a major advantage of those reactors. And you've probably seen on Twitter, a lot of people want to use or say they can use these to fire up coal burning plants.
Yeah.
And to some extent, that's true. Not quite as easy as people make it out to be, but it certainly can be done. But the best use of it is to not use the steam cycle at all, right? Because you're losing 60% of the energy that you produce straight out into the cooling system. And that's, if you can use the energy more efficiently, then you don't need such a big reactor. Because, you're producing, from the thermal energy of a plant, you're probably only using about 40% of it to actually end up as electricity going out the door. The rest of it is gone as waste heat to the lake. Also means that you don't need them near a large body of water. Gives you a lot more independence in siting. So there's that type. So one of the limitations of conventional nuclear reactors is they are right on the lower end of the steam capability of most turbines. So the steam is very wet when it comes out of the boiler. Once it's gone through the high pressure turbine, there's too much water in it. So you have to put moisture separators and reheaters, which are expensive pieces of kit, to reheat the steam and then put it back into the LP turbines, low pressure turbines. So if you can increase the temperature of the steam output from a reactor, then you are able to do a lot more things with it. You can use it for process steam, for example. Current reactors probably couldn't give you much in the way of good quality process steam. It would be too wet. But one of the best uses of them is like I say, on when the newer reactors can have much higher temperatures and much higher steam temperatures. Some of them produce high temperature gas, like the HDGR does. Some of them produce high temperature steam. There's yet other designs. So, this is just a small snapshot of the hundreds of designs I've seen, literally hundreds now.
Yeah.
Brilliant people working on them. I mean, the TerraPower one that Bill Gates is working on. I mean, it's genius, pure genius, absolutely brilliant reactor. Yeah. And, if these things can be deployed, in a sensible way, that they are going to completely revolutionize industry. Instead of having to get shipments of fossil fuel in, you can have your reactor running for decades, literally. Some reactors, you can just fuel them once, and they're actually in pods. They call them micro reactors, where if you wanted to provide hot water, say, for maybe a little bit of electricity, you can get a 5 or 15 megawatt thermal reactor, put it at a site, and leave it there for 25 years. And then when you don't have to have any fuel supply ever for that site. To me, those are the things that are really going to make the difference.
Yeah, that definitely will make a difference. I agree. Uh, Malcolm, what do you consider the best balance energy mix for the big countries like US, Canada, China? How much of the mix should be nuclear energy in the terms of percentages?
That's a tough question.
I mean,
If if
what would be
if
the best balance? We can go 100% nuclear, or that's not even possible.
we
But
could, one of the problems with doing that, if you nuclear could do it all, especially with the new small modular reactors. One of the features of some of them is that they can load follow. So as the load goes up and down, you don't want to do that with a big reactor. You don't want to change the load on it. You just turn them on, leave them running, and let them provide base load power. That's the best use. And the
yeah,
reason for that is the high capital cost. You don't want a machine that is shut down part of the time because it's not paying for itself. When it's not
yeah,
running, it doesn't produce revenue. So when you
exactly.
start decreasing the number of megawatts output, then you decrease the number of dollars input to the company. So you don't want to be doing that with large reactors with huge capital cost. With small modular reactors, I'm not sure of the economics of doing it. What I've seen is that the SMRs are also probably best run at base load because they're not going to be that cheap either. You know, the cost per megawatt isn't going to be that much different to a large nuclear plant. I don't think. I'm not an economist, but you know, it's possible that they could load follow. But if they do, then you've got a high capital cost piece of equipment that's not producing its maximum output all of the time, and therefore its costs are going to go up. It doesn't matter, you know, from a maintenance point of view, it doesn't matter whether you run it flat out or, you know, if you've got a 300 megawatt plant, doesn't matter a hill of beans whether you run it at 300 megawatts or 10 megawatts. The
Yeah,
maintenance is still the same, the overhead costs are still the same. You're just not getting the revenue from it. So bearing in mind that nuclear could, if you're prepared to pay that economic penalty, do it all. I don't think 100% is the right mix. I think it has to be probably nuclear should handle all of the base load. That's the first step, you know, to decarbonize, if that's what you want to do, is to increase nuclear so that it produces all of the base load power. Excuse me.
probably.
Um, when you want variable power, um, probably there needs to be some gas turbines in there, I think. Wind and solar, I mean, I'm not against them particularly, but they are very variable. And you know, you got the same problem that you've got a piece of equipment that you're running at, you know, 25 or 30% of its capability, but you've invested all that money and you're not really, it's like Ford building a factory, you know, and it only runs 3 days out of every 10. I
Yeah,
mean, it would go broke really quickly. And that the same logic applies to nuclear and to wind and solar. You know, you have to have the capacity factors there to pay for the machines. Otherwise, you're going to go broke in a real hurry.
exactly. Do you see coal out of the game in 30 years? I mean,
In 30
100% out
years,
of the game.
yeah, I think coal is going to be phased out for two reasons. One, I think once the production line of nuclear reactors gets underway properly, and if the COP28, you know, commitments actually comes to reality, then
Yeah,
yeah, you know, nuclear costs will come down, and the more you build them, the cheaper they're going to be. Um, and you've also got, you know, much more skilled workforce. Part of the problem has been, you know, cobbling together as workforce that can actually build these things nowadays, like, you know, BC Sumner and Votal. I mean, they suffered from that significantly. I mean, you know, fantastic job that was done, but you know, they didn't finish Sumner, and and Votal was quite late and a little bit more over the budget.
yeah, yeah,
So you know, it's if you want, it depends on your objective really. If your objective is to have a reliable power system that is not subject to the weather and is decarbonized, then it has to be 100% nuclear because wind and solar are too unreliable to run an industrial economy on. People, Germany's going through this right now. As a case in point, a lot of industries can't afford the prices in Germany, so they're leaving. Michelin just announced they're closing up in Germany now. Excuse me. So, if you want to decarbonize, if that's your main goal, then making the whole system nuclear is the best way for you to get reliability and to run an industrial economy without worrying about the weather.
Mm-hmm.
If you want to close coal plants, then coal plants are mostly baseload power. They're not always. They can ramp up and down pretty quickly. I did operate a coal plant at one point in my career for a few weeks, so I know they can do that. The other thing you can do with coal is, if you don't want to throw away all that investment in equipment that building a coal plant, it's 10 years old and shutting it down, you wasted an awful lot of money.
Yes.
I'm not sure we can afford to waste that kind of money. So replacing the heat source with a nuclear reactor might be a good solution if you want to get rid of coal. The nuclear can displace coal, there is no question.
Yeah.
It can easily displace baseload coal stations, and it has done that. In fact, we did that in Ontario. We had actually the world's largest coal burning power plant in Nandicoke, and beautiful place. I went down there many times, but when you see the tons and tons of coal going in this place, it was 4,000 megawatt plant, huge. And we started up Bruce units 1 and 2, and essentially were able to shut down Nandicoke as a result. Plus a little bit of wind was in there too, so give them some credit. But mostly it was the heavy lifting was done by the 2 nuclear units that came back online, and we got out of coal completely. We had other smaller coal burning plants around as well, so we don't burn coal anymore. Ontario is really a poster child for how to do it right. Don't want to bang the drum, but this is just a little personal anecdote. Where I live, I used to look across into Toronto from Darlington, and it's a nuclear power station where I work. And you look across, and every morning you'd see this haze of yellow in the distance, and it was quite noticeable. On many, many, many days I saw that. A few years later, once they shut down Nandicoke, it was gone. The air quality in Ontario has really improved a lot.
Really?
It's by every measure that they've done, particulate matter, gases, everything else they measure. It's a difference. We've done some of that. I don't want to give them, rule them out, because we have quite a lot of wind power here, and it has had some effect. But you gotta have a big power source in order to do it right, and that's got to be nuclear. If you think you can, I think you're dreaming.
Hello, everyone. My name is Lucian. Most of you know me from Twitter as Triangle Investor.
Not against it, but you got to have big power sources in order to displace coal.
Yeah, you're right about that, Malcolm. You stated in one of your tweets that we need new mines, not only for new production, but also to replace declining production of existing mines. And I quote you, generally, miners access the highest grades first. Over time, ore grades decrease, therefore produced pounds will decline.
Yep.
Malcolm, my question is, how much of new uranium mines we need from the one that are already in projections for the next 10 years?
Oh, well, I mean, the next big one to come online is Arrow, Nexgen's Arrow. I am invested in Nexgen, so you can take what I say with a pinch of salt.
Yeah.
But it's a 29 million pound a year mine. That's bigger than Cigar Lake and MacArthur River almost put together.
Yeah.
But they can only do that for 5 years. And that's because, like any business, they're going to make the most profits they can. And they're going to design the mine so that it gets at the highest grade uranium first. Cigar is like that. MacArthur River is like that. So that, after a few years, the the ore body is going to be mining lower grades, and you never really know what you're going to get out until it's gone through the crusher and you've actually got uranium. You don't know. That's people think that mining is some predictable business. It's exactly the opposite. It's very, very unpredictable. You don't know what you're going to get until you've crushed the rock and you've got it in drums. That's it when you know. And all the Ni 43s are just estimates. That's all they are. They're pretty good. And I'm not saying they're wrong, but they are estimates, and you really don't know what you've got until you mine it. It may be better or it may be worse. Generally, it's not as good as you think it is, but Arrow may be different. I don't know. But Cigar Lake and MacArthur River, I think they've got. Last time I looked, about a year ago, they had 9 years left. So about 8 years they've got left, both of them. They may find new ore, because another thing that they do is when they're underground, they do drilling underground into different where they think there might be more ore bodies, so they can extend the life of the mine that way.
But that will be for 1 year or two, maybe, not more, probably.
That's right. It's not going to extend it by another 10 years, that's for sure. They Cameco's got most of the good stuff out of Cigar and MacArthur, I think. You have to ask their geologists that, and they probably won't tell you anyway. But that's the truth of the matter. Mines deplete, and all miners go after the top grades first, because that's where they make the money. They've got to get a return on their capital. And you want to go after the high grades first, so that you get that return on capital faster. And Arrow will be just the same. If you look at the proposed mining output chart from Arrow, it's 29. I think it's 28.8 million pounds average for the first 5 years. Then it drops off, so it starts to go down. But 28.8 million at whatever it is, $83 a pound is pretty good dollars.
Malcolm, do you really believe that they will produce uranium in these decades? I mean, it's a big investment, it's a big mine. They will probably have also some challenges on the way. So do you really believe that they will produce like 2029, 2028, or even 2030?
Yeah, I mean, the board of directors and the management team there is going to give you the optimistic number. That's their job.
Yeah.
I don't fault them for that. But because I'm a realist, I know that there are a lot of things this time around that are different from last time, and one of them is labor shortage. Running a mine takes skilled labor, a lot of it, and these mines are in the middle of nowhere. That's no disrespect to the First Nations that live there.
That's
but
a
they
fact.
are far out.
Yeah.
And I've the places where these are absolutely beautiful areas. They really are. Just Canadian wilderness in its all of its beauty. But they are long ways from centers of population where a lot of people don't want to do 3 weeks, fly in, fly out for 3 weeks. A lot of people don't want to do that.
Yeah.
Younger people particularly. So, they've got to get the manpower from somewhere. And one of the good things that Nexgen's done, and I think the other miners are doing the same thing, is to train the indigenous workforce in how to do some of this stuff, which I think is a brilliant move. Why bring people in, from 1,000 miles away, when you've got local populations there that will be, that are in need of work, and the reason they can't do it is because they're not trained. So that's a good feature of what they've done. The town of La Loche is not that far away from Arrow, so and it's going to be an area of high development. So training people in that town to work in the mines is I think is a really good move, and that may alleviate some of it.
Yeah.
But my big concern is labor shortage. That's the number one.
Yeah.
Money is not an issue really. They can raise it many different ways. I think Nexgen's had lots of offers on that front already, according to Lee Courier.
Yeah.
And So I don't think raising capital is going to be the issue, and I don't think paying it back is going to be an issue. I think they can produce it for less than $10 a pound. You can't get much better than that. But
It
proof of
can
the pudding,
it can be better. I believe the Denison even has better
yes,
economics with Wheeler River, and I frankly I believe that they will be the one that will produce first in the Athabasca. Well, especially they will be the pioneers with ISR methods over there. But let's hope it will all turn out okay. And what do you think about Denison Wheeler River project, and what do you think about Triple R from Fission?
well, they're very different deposits, but
Yes.
Wheeler River is the first ISR in Canada. So because of that, I have some reservations that it'll all go smoothly. The test results that I've seen have been really encouraging. So the process works on an experimental scale. On a big scale, that's a different matter. I think it probably worked. They got good people there working on it. So I
Yeah, but
think,
they have extracted uranium. That's a fact. We
yeah.
cannot change that. Yeah.
So they know the process works. Now they've got to increase the output of it. So, and
Definitely.
that's not such a bad thing, but increasing the output of anything in nuclear is never straightforward. Things that work on a small scale don't necessarily work as well on a big scale.
Yeah.
So, when you're producing, millions of pounds a year, then that's a whole different ballgame. Denison has a first-class management team. I have no doubt that they will do it. I think they're probably going to come online just a little bit before Arrow. I think Arrow is more likely going to come online about 2029, then maybe 2030. I think that's more realistic, because nothing ever goes smoothly. To think that things go, tickety boo all the way through
Yeah.
in
Yeah.
nuclear is it just doesn't happen usually. On the odd occasion it does, but it's rare. Maybe these two will be the exception. I hope they are.
Yeah. You never
And
know.
they've certainly got really good teams working there. But ISL has never been done in Canada before. Um, but it's certainly a cheaper way of doing it. There's no question. The machinery that you need is a chemical process rather than an industrial process where
Exactly.
you're bashing rock to bits. It's those machines are gigantic. Size of a house. So you haven't got that expense with ISL mining. If it works, I mean, it'll be something to consider for future uranium mines. I don't know whether whether Nexgen thought about it for Arrow. I doubt it because it's so deep.
Yeah, it's probably
It's
too deep.
yeah, 600 or 700 meters deep. That's a long way to pump chemicals. So I think it's out of the question for that. You got to go to this long slope stope mining methodology for that. That's the same as Triple R is using that method too, but it's shallower. Triple R is really interesting because most of the current ore body is underneath Patterson Lake, and it doesn't have as much as Arrow does. So it's a smaller output mine, but it's shallower, quite a bit shallower than Arrow is. So that's got pluses and minuses. I think one of the things they're doing is digging the shafts and then tunneling through underneath the lake. They're freezing the interface between the bottom of the lake, and because that's sandstone, and the mine itself. So they're putting a freeze layer there, which I thought was quite an interesting way of doing it. Time scale for production, not sure when. I think they're probably going to be all about the same time. I think Denison will probably come in first with Wheeler. Arrow will be second, and about the same time as Triple R.
Yeah.
But Triple R has, that it looks as though there are other opportunities there finding ore bodies. They may be disconnected, like the pearl effect, string of pearls. There's a blob there and a blob there and a blob there. So I think that's what Triple R will actually turn out to be. But like I said before, proof of the pudding is in the mining. you don't know what you got, and it's like Forrest Gump, life is like a box of chocolates. You don't know what you're going to get. That's
Yeah,
mining.
exactly. You got that right. And Malcolm, one question. Do you see artificial intelligence more in uranium mining and exploration? Is this technology knocking on the door of the uranium and general exploration and mining?
That's a really good question. I mean, AI is going to affect a lot of things in engineering, no question about it. From simple things like writing reports, excuse me, to analyzing data. And that's what mining is. It's analyzing a lot of data using human mind, intuition, experience, whatever, to tell you whereabouts to look for stuff. AI can do that. I'm not sure that it's up to it just yet, but there are new technologies coming along for finding uranium, and one of them that I really forgotten the name of the company, but it's out of British Columbia, the University of BC, and it detects muons from outer space, and they put the detector deep into the earth, and by analyzing the the detection of muons, they can figure out where the ore bodies are, because it
Great.
changes.
That's
And
excellent.
when that company goes public, I might buy some because that is incredible technology. If you want,
Share me
what
the
we do,
ticker when it's IPO, when it has IPO, please let me know.
I could remember the name of it, I'd tell you. But yeah, if you look it up, it's muon interference or something like that. It's called. But and it's not just for uranium; it's for a whole bunch of other things. It takes the mining or looking for ore bodies it's a little bit of a crapshoot. You've got to have a bit of luck, and you've got to have a lot of expertise to drill the holes in the right place, because they're expensive, drilling holes in the ground. So if you can find technologies where you don't have to do all of that, like this muon technology, that'll certainly help. And if you pair that with AI, I think the frequency that you'll find ore bodies in the future is going to dramatically increase. We really don't know where this stuff is. We didn't think there was any in the Western Athabasca Basin until a few years back.
Yeah.
Nobody expected a 29 million pound a year mine to be there.
You got that right.
Nobody.
Yeah.
I remember the very first time that Nexgen put out the drill results, and I looked at it and I thought, holy smokes, like that, there were nearly 30,000 counts a minute. And I thought, knowing what I know, that's probably got to be uranium. So I took a bit of a gamble on it, and it's paid off really well.
I can imagine that. I want to hear your thoughts. Let's touch a little bit on the uranium market. I always like to hear other prognosis about the uranium price. I know that you don't have a crystal ball, nobody has it, but where do you see uranium in the next, let's say, 2 years? Where do you think uranium price could settle in what would be the peak price of uranium, of this uranium bull cycle, so to say? Potential.
Well, hold on, I'll just get my crystal ball out here, polish it up.
Yeah, and
when this all first started, I had said I think it was on Stockhouse or one of those websites, can't remember which one,
yeah,
that probably go to $200 a pound. And the reason for it was Justin Huhn of Uranium Insider doesn't agree with me, but
yeah,
about that. But what I saw was that if the same dynamics repeated themselves, then if you simply took compound inflation from the $137 a pound, you would easily get $200 a pound within a few years. In fact, when I did it, it was 190 something, I think.
yeah, almost 200, right?
I said, and on that basis, I said, well, if we have the same conditions as last time, then yeah, $200 a pound is doable. And I got crucified for that, of course, because all of the experts out there said I was full of it. But where are we now? 83.
Yeah.
It's not a far cry from 200. It'll easily get to 100, 200. It depends a lot on what goes on in Kazakhstan, I think. I heard yesterday, a day before, that they were running short of sulfuric acid, which is, they're all ISL mines there.
Yes.
If you produce it, you can't mine. End of story. And Kazakhstan's a pretty remote place, so I can understand. Procuring it and getting it there is quite a challenge. Amazing they do. It's not like you've got industrial facilities every 5 minutes that you can go and pull this stuff from. You can't. It's got to be brought in to the country. I don't think they have a sulfuric acid facility there. So if they run out of sulfuric acid, then their production rates are going to drop. And they're the world's biggest producer by far. What does that do? Well, it means that they may not be able to fulfill contracts to their customers, or they'll provide less, or extend the contracts. All kinds of ways they could work around it. But if you're not producing what you thought you would, something's got to give. And is that going to go to China, or is it going to go to Russia? I don't know. I think it's probably more likely to go to those countries than the West.
Yeah, I believe small portion will come to the West, and the rest will go, we know where. Malcolm, I want to touch on your uranium portfolio. You hold uranium stocks in your portfolio. Tell us which ones.
Well, I have a
Plain
lot.
and simple. What's your biggest position? Let's start this way. What is your biggest uranium position?
Well, that's easily Nexgen by far.
By far, Nexgen. And
probably about 50% of it is in there.
Okay.
For obvious reasons. I did. It's been a fantastic journey. I mean, I bought it at 60 cents, and now it's $9 something. So,
nice.
Pretty happy camper.
Yeah.
Will it go further? I don't know. It almost certainly will, because none of these. One of the things that you've got to remember about all of these uranium exploration companies, and I have most of them, not too many in the US. I think I've got UEC. I think that's the only one I've got in the US. Wish I'd bought Energy Fuels, but I didn't.
Okay.
But I've got Nexgen. That's the biggest position. Denison Mines. I have UEC.
Chemical.
No, I don't have Cameco. I don't have Cameco at all, because the upside is less than for the amount of money you've got to invest. Even I would have done okay if I'd have bought Cameco 5 years ago, but it's still nowhere near the returns that I've got from Nexgen and some of the others. Denison Mines. Where to get to? Apia Energy I've got, because they've got the Elliott Lake mines, the one I mentioned earlier in Ontario. That's the uranium, potential uranium mine. They're looking at starting those up. When they'll do that, I don't know. A lot of capital required, of course. But they seem to have moved off to rare earths, which is also a good area to. I'm also invested in rare earths, so that was a natural fit for me. And what else? Don't have Energy Fuels.
Do you have any small caps, explorers?
Yeah, F3. I have Fission. I have. That's about it. I think that's the biggest ones. Pure Point. I've got a little bit in that. That's a just an explorer. Potential upside is good. Mega Uranium. I have. But mostly I have that and Boss. I have Boss uranium as well, and I have that mostly because of its shares in Toro and Nexgen.
Nexgen,
It's a
yeah.
huge shareholding because they used to own that property. Like Mega Uranium used to own the property that Nexgen is now mining or about to mine.
Yeah, yeah. And
I think they may be kicking themselves and sell that.
my question is, so you said you bought Nexgen for 60 cents and now it's gone like more than 10x. Have you considered to take some money off the table?
No, I could. Don't need it, so I don't really see the point in doing that. My philosophy is it's probably not going to go down from here. It's going to go up and down like all stocks do, but
Yeah.
it's not going to go too far down from where it is now. You're not going to see it drop to $5 or something like that. So it's going to fluctuate. And my goal is when they start mining, if they get to that point without being taken out, which I think they will. Listening to their management team, I don't think they have plans to sell it. But there's lots of things that can happen on that score. Major oil company might want them. Could be all kinds of reasons they would get taken over, but I don't think so right now. Certainly not in the next 5 years.
Okay.
That's my hunch, and it is a hunch. I don't know for sure. But once it starts mining, its revenue is enormous. Like something like what did they calculate it? $2.5 billion a year.
Yeah. It's a
That's
cash
clear money.
machine. Yeah,
I mean,
yeah,
that is just a cash machine. That's
yeah.
better than anything that Kamiko has. So, yeah, will it go from $9 to 20? I don't know. I don't need the money, so I'll just leave it.
Okay,
And if it goes up a bit more, good.
yeah. I will ask you about certain uranium companies, and I would like you if you can tell us what are the pros and cons for that stock. Let's start with let's say Denison. What is the plus? What is the minus in that company? What do you think?
Plus, is they've got some good deposits. Both Phoenix and Wheeler River are very good deposits of uranium. Uh, Another major plus is they have part ownership of a uranium mill.
Yes,
That is worth a lot of money these days
yes.
because uranium mills are going to be in short supply. They're building one for Arrow, but that's I'm not sure. I think that's going to be tied up with Arrow ore. So I think that's one of. I think it makes Denison a really attractive takeout target for Kamiko. I could be completely speculating here and full of it,
Oh,
but
it has some synergies. I would have to agree on that. There
you
are
know
some
I
synergies that could be potentially interesting to Denison and to
there
Cameron.
are very much so because Kamiko has experience in ISL mining in Inkai, so it knows that process. Denison has an ISL mine, the first of its kind in Canada, so there's definitely synergy there. Kamiko, if they were bought out by Kamiko, they would also have that mill capacity, which is very useful right now, and going to be in short supply as time goes on. They've got a hard rock mine in Phoenix. They may convert that to ISL, I don't know, but right now it's going to be a regular mine. So there's a lot of, and it's very close to Kamiko's existing operations. They're not
Yeah,
that far away geographically. So to me, it makes a whole lot of sense that, they would be looking at each other and doing a deal. The way Kamiko tends to operate, and I have massive respect for their management. I think they're the best in the business. Gitzel and the other guys there. The how they'll play it, I don't know. Generally, Kamiko prefers joint ventures, so I could see them doing a joint venture with DML. I think that might be more on the cards than an outright takeover. But Kamiko's got the cash to do it. It's got $2 billion in the bank, so it could easily do it.
yeah. What about the minuses for Denison?
It's a small company. It doesn't have a lot of cash like Kamiko does. That means it's going to have to raise money to build mines and do the things that are necessary to get into production on a big scale, because it doesn't produce on a big scale right now. It's nothing like the amount of pounds that Cameco produces, and it is solely a uranium mining operation, whereas Cameco is diversified, especially with their purchase of a stake in Westinghouse. It's a very diversified fuel manufacturing company. It's not a miner anymore, in my view, although that's one of its main lines of business, not the only one. Whereas DMO is just a miner, so it's a near-term production mining operation. So that's the weakness of it, because they're going to have to develop. They got to raise capital somehow, and I think that's another reason why I think a joint venture might be the way to go, because that'll give them access to capital and enable them to develop their mines to full production.
Yeah,
It's always the danger of these companies, right? You found the stuff. Now you got to build. You got to find $1 billion or so to build a mine into a production capability that is going to earn you revenue. So it's kind of the cart before the horse. Joint ventures are a nice way around that. You don't lose the company, but you get the access to the capital that you need. And
yeah,
I think that's on the cards for DML.
yeah. Sometimes that makes sense to do a JV. What about ISO Energy?
I don't know an awful lot about ISO. I mean, that it was a spin-off from Nexgen. It's got nice deposit there. Um, they've got to get it into mining like all of the other mining companies. And again, that takes money, a lot of money.
Yeah,
And there are technical things that can go wrong with all of this. Since when you're using somebody else's money to develop a production facility, it's hunky dory when things go well. When things don't go well and things take longer than you anticipated, the people you borrowed the money from want their money back. And that you get into these push and pull situations where you're desperate to get into production, but you haven't quite got the money to get into production. So that's the same with all miners. I see that as the major weakness of ISO, but it's a good company. They've got lots of good team there working on it. I'm
yeah,
sure they'll get into production.
yeah.
How the key is always how do you expect them to raise the money? They're going to do it by share dilution,
It's
or they're going
always
to do
about share dilution in most
it.
of the cases. Yeah, and
This is the way they're saying exactly that.
yeah, yeah. Malcolm, what about UAC? What are the plus? What is the biggest plus, and what is the biggest minus?
Um, Biggest plus is right now anyway. It's an American company, so it's going to benefit from a move towards more US centric uranium production. I've seen a few pieces on Twitter about the bill that's going through Congress right now. The uranium production in the US has declined so much.
Yeah,
It's almost non-existent. I think there
yeah,
was one year when they hardly produced anything. So to bring that up to the point where they're producing even a two-digit percentage of US consumption is going to be a tall order. But companies like UEC and Energy Fuels are the lead companies that are going to do that. So there's a lot of upside to them. They're either going to have access to money to develop the mines from the US government. There's a lot of positive things going on that would affect their share price,
yeah,
and it is affecting their share price already.
yeah,
So
yeah.
it is the only US one that I own, but I like it. It's a good company. They're going to produce a lot of money down the road.
Yeah. What about F3 uranium?
Ah, now you're talking. I do own F3, quite a bit of it. Um, it has a lot of similarities to Arrow, many similarities to Arrow, although it's shallower. Um, it's not that far away. It's on the Patterson Lake corridor, the same as the other finds, Harpoon and Spitfire, which is Pure Point, I think Spitfire is, and all the way along there. So it's the southern, the southeastern, southwestern end of the Patterson Lake corridor. So I can see that whole corridor being a major uranium production facility to equal the eastern side, in the not too distant future, probably by about 2030. It's in its early stages yet. I mean, there's some pretty spectacular drill results. I mean, they're better than Arrow, but because you get good drill holes doesn't mean you've got millions of tons of uranium. It means you've got a good drill hole. That's what it means. You have to do the whole Ni-43 analysis to even get a good estimate as to how much is there, and they're far from completing the drilling cycle yet. Will it be another Arrow? I certainly hope so. It's got all the hallmarks of it. You don't get grades like that by accident. And they also found boron in one of the drill holes, which is a really good indicator of uranium.
Yes.
It's nearly all in that part of the world. It's nearly always found with good quality uranium deposits.
Yes. Yes. Yes.
So,
Yes.
so the indications are good. It's a junior mining company. It's a small, very small outfit in terms of dollars. Financing is always their issue. They're not making any money. Like most of these miners are not making any money. They only make money when they're actually selling something. That's why guys like Warren Buffett don't invest in explorers, because they don't make anything. They don't make millions of cans of Pepsi Cola a day.
Yeah.
Actually, that's the wrong one. It's Coca-Cola. Oh dear, slap my wrist. That's terrible. So, they don't make anything right now. So they're purely speculative. People should always bear that in mind. You're not buying shares in a Walmart and, that's got a balance sheet and money coming in every month. You're buying shares in a company that may or may not produce money in the future.
Yeah.
And you paid your money and you take your pick. There's a lot more to it than that. When you see drill results like F3 is producing right now, and consistently so, I think you can pretty much come to the conclusion that they've got some uranium there. Probably right now, I'd put it at about maybe 20 million pounds, which is far from Arrow, but they're going to expand that and they're going to drill further down, and that they'll gradually, they'll do their step out drilling to see what they've actually got. But 5 years.
Good thing about F3 uranium is that property is explored, like 5% of the property is explored.
That's correct. That's a very good point. Yeah.
Yeah. So
there's a lot more potential there, but
exactly. It can be much more. Tell me, Malcolm, can you name your top 3 or 4 or 5 uranium company CEOs that you respect the most?
Just in miners. Respect for different reasons, but I think top of that list is Tim Gibson. I think what he's done buying a stake in Westinghouse is pure genius. It completes the whole fuel cycle for Cameco. Now they can manufacture fuel for every reactor in the world, just about.
Yeah.
They already have the contract to manufacture fuel for CANDUs, so that's taken care of. They're not the only supplier, but they're one of the main ones. That to me is a coup d'état. That's just such a brilliant move on their part. I know there's a lot of negotiation went into buying it, but what an opportunity for them. So, and Grant Isaacs as well. He's not the CEO, but those two together are a formidable team, and I think they're going to make Cameco into a much bigger company than it is now, especially if they get the laser enrichment process going. So yeah, top marks to Tim Gitzel. I think he's the top of the list.
Give me another one. Give me one more.
I like Adnani, if I pronounced that correctly.
Yes.
He's a smart cookie. I've seen a lot of his presentations and really like the way that he thinks. He's gonna develop in the uranium industry. I think he's gonna be a major player. Korea, he's an interesting guy. I've never met him, but I would like to. He's really to have had the foresight to start to explore in the Western Athabasca. I think you've got to have quite a bit of nerve to do that, and to risk a lot in going after something which you've got a hunch about. Um, it was more than a hunch. I mean, there were drill results from years back that they used when they bought that property. But you got to hand it to the guy. I mean, he's gone from nothing to almost on the verge of a $2 billion, $3 billion a year company in the next 5 years. I mean, as a CEO, that takes some doing.
Yeah, I agree. But I will have to ask you, do you, I don't own Nexgen, to tell you the truth. The disclaimer, I don't own that stock. Do you mind their G&A numbers?
Sorry?
Do you mind their G&A numbers? The amount of cash they're spending on G&A?
Yeah, I think they're spending probably before they're kind of like spending on a credit card. You got to pay it back sometime. Yeah, if they run out of capital, that could be a serious matter for them. I'm not sure that they will. They're certainly burning through money at a rate, but they're doing it on the back of the world's biggest uranium deposit. So can they afford to do that? Maybe. I don't know.
Yeah, they are doing it.
Yeah, I mean, it's exactly what they are doing. I mean, if they run out of capital, then they're going to be in big trouble. They've got to sink a shaft, two shafts in the near future, the ventilation shaft and the actual mine shaft.
Yeah.
Those are some of the expensive bits of mining. It's going to chew through cash pretty fast. So, am I concerned about it? Yeah, a little bit. Will they be able to raise the money to do it? I don't think they're going to have too much of an issue with that. But they're doing a few things that I find a bit bizarre. The F1 sponsorship being one of them. Yeah, I mean it's not big money. I mean it's neither here nor there really. But do you want to be spending any money when you've got all this big engineering stuff to be doing?
Yeah.
That's the only question mark I've got about Nexgen.
Okay.
There may be an awful lot of money, so
Yeah.
I really can't be too critical of them. But yeah, I do see people's point in that that these frivolous or what they consider to be frivolous expenditures are probably not the right time to do that. Maybe when they're mining a few million pounds a year.
Yeah, exactly. That's my point also. Malcolm, we have only a few minutes left, then I will let you go. I have questions from some of my followers and try to keep them short, like 30-second or 1 minute
Yep.
answer. First question, but you already answered the big part of that question. Can you compare Nexgen Arrow, Fission Triple R, and ISO Energy Hurricane to what F3 Uranium has been drilling? How much better is F3 drill results so far? And do you see similarities from when you were invested in Nexgen back in the day, or you are still invested in Nexgen?
Yeah, there are. Some of the intercepts on the F3 drills. I mean, they're over 30%. That's unheard of. That's better than Arrow. There's no hole in Arrow that was up as high as that in any intercept. They were mostly in the low 20s,
Yes.
which is fabulous for a uranium mine.
Yeah. Yeah.
But when you have those sorts of, because it makes mining so much cheaper. If that's actually the case and they've got a big deposit at those levels, then it's another Arrow. Don't know that yet,
Yeah. Yeah.
But the bottom line is got to make money.
Yeah.
You make more money when you got good grades.
Yeah. Yeah.
That's simple.
The next question: do you like Peninsula Energy?
Yep. Yeah, I like them all. I mean, every uranium company is going to do well in the near future. In the next 5 years, especially with this COP28 announcement. If that actually comes to fruition, we have nowhere near the number of uranium mines that we need. So every explorer is going to be, people are going to be throwing money at them to find uranium. Whether it's utilities that buy them out or oil majors that may be.
Yeah.
I could see that happening. That's been going around Twitter for a while. They're all of them. I don't think that any of them are really going to have a difficult time in the next 5 years, unless they really mismanage their affairs.
Yeah.
I don't own Peninsula,
but you like it. Okay, I got it. Let's move to the next one.
Right now, I don't think there's any uranium company that is going to give you bad returns unless it's got a crappy management team, but most of them don't.
Yeah. Next question. Do you believe that with big nuclear fleet expansions throughout the world that we are risking too much of more serious nuclear accidents?
No, no, I don't think so. After Fukushima, the industry learned a lot of lessons. It was a big wake-up call. When Chernobyl, should step back a little bit of nuclear technology here, but when the nuclear industry has all kinds of different accident scenarios for which they have to cater, and they're called, for example, in an earthquake, in the area where you're going to situate your nuclear power station, you decide what is the design basis earthquake. In other words, what earthquakes does this area have over the last 500 years or whatever, and then you design to that. The problem with Fukushima is very similar to an earthquake, but it was a design basis tsunami. They got hit with the beyond design basis tsunami. They had never anticipated that, and it wasn't included in their designs. Otherwise, they wouldn't have put the diesel generators in the basement where the seawater could get in, or they would have protected it somehow. They didn't do that because they never thought the water would get there. Now you'd probably put those diesel generators up on the hill somewhere, or out of harm's way. The sea change, pardon the pun, but the sea change that Fukushima brought about was a widespread consideration of beyond design basis events, so that you design it to a certain set of criteria. You could design it, for a, category 50 earthquake, but there's never been one. And you could design it that way, but it costs you hundreds of millions of dollars more. But you don't want to do that. You've got to be cost effective. So you design it to the design basis event, but you put in place other measures so that if you get a beyond design basis event, you've still got means of cooling the reactor and making sure the fuel don't melt.
Yeah.
And that's what we learned from Fukushima, is that beyond design basis events are possible, and we have to cater for them. And that thinking is now throughout the entire nuclear industry, right from the chief execs right down to the guys on the shop floor.
Yeah.
So
Right.
will it happen again? You can never say never, but the probability is extremely low.
Of course, of course. Malcolm, the next question, name 5 best guys to follow on Twitter. Or girls, of course.
Triangle investor.
Thank you very much. You
I
have
read everything.
four more to come.
Quakes, of course. I mean, Quakes is just, amazing amount of information that man produces. Really have to thank him a lot.
Yeah.
U308, I read quite a bit. Higo from Australia.
Yeah.
Very interesting guy to talk to. That's about all I can remember right now. Who else is there? And Rod Adams. I like Rod Adams because he has a lot of really interesting stuff on. He's very knowledgeable about uranium, and he writes some really good posts on sometimes the politics of it, and and there's always politics in uranium.
Yeah.
So he's a good guy to follow as well. Those are it, I think. Did I get to 5? And me, of course.
No, one is missing, I believe. No, or you did it. Sorry. Yeah, 5. Sorry. 2 final questions. Short answer, please. What is your favorite uranium mining jurisdiction?
Oh, Athabasca, for sure.
Okay. And the final one, what are the biggest disadvantages of thorium-based nuclear power?
Lots of thorium about, but there's only one thorium reactor that we know in existence, and that's in China. It's actually just started up. It has a lot of advantages, but I'm not sure that the advantages outweigh all of the extra research and development you've got to do. We've got reactors that work down the road, certainly worth investing some money in them. And money has gone into them, that there were experimental thorium reactors. Thorium reactors don't stop nuclear proliferation as many think. It runs on U-233 instead of U-235. But U-235 reactors don't actually run on U-235. They run on plutonium mostly, which it creates from the uranium. So most of the U-235 isn't burnt. But U-233 is actually a better material for making weapons than U-235 is. And that's, weapons don't use that anyway.
Yeah.
Just not as much as they used to.
Yeah, I saw. I have another one. Sorry. What is the last question? What is your favorite uranium stock? But I believe that you answered that. That is Nexgen, right?
Yeah. I mean, I'm biased, so if there's one that I don't have, which removes the bias,
Yeah.
I'd say bit of a toss up between Deep Yellow and which is John Borshoff's company,
Yeah.
and Bannerman, which is
Monroe.
Monroe's company. Yeah, I like them because they're big deposits and in a friendly jurisdiction in Namibia. Actually, Brandon did invite me to Namibia.
Really?
Yeah, he did. I have to go there one of these days. He
Brandon
lived
is a
there for
great guy.
6 years, so he knows the area pretty well. I would
Yeah,
like to go. I've never been to that part of Africa.
that would be a great trip. I agree. Thank you very much. This was Malcolm Rawlingson. It was great talking to you. Thank you very much for this, and let's discuss more often.
No, thank you very much. It was great to be on.
Thanks.